Hello, in this video, we'll be talking about Coulomb's law in vector form. So, because force is a vector quantity, so it's very, mandatory or it's very essential to, represent the Coulomb's law in vector form. So let's consider two charges. Let this be charge 1, Q1, and let this be charge 2, Q2. And let they are separated by a distance R, okay, by this distance. And let me take the origin. Let's suppose this is point O, the origin, and this distance, this is the position vector of this charge from this origin from O. Okay, this is R1, and this is the position vector of charge Q2. This is R2, position vector R2, and the position of this vector is this is in this direction and this is in this direction. So this Coulomb's law, we know that is equal to F is equal to K Q1 Q2 divided by R square. This is the scalar form of this law. And if we are to represent the Coulomb's law in vector form, so I will write it like this. But here the main thing is here is that the force will be on this charge Q1 due to Q2, and let me represent that force by force on charge first due to second F12, and there will also be a equal force but in opposite direction on this charge Q2 due to Q1, and let that force be force on second due to first F21. Okay, and if I go from point charge Q to point charge Q2, so I will go in this direction. This will be R12 direction, okay, R12 vector from Q1 to Q2. And if I go from Q2 to Q1, I will represent this by this distance by R21, by vector R21. Okay, so if I have to represent this force F12, force on charge first due to second, force on charge first due to second, that will be equal to K Q1 Q2 divided by R21. Okay, R21. So here I have to take R21 because uh, I have to take that direction in which this force is acting. As you can see, this force is acting in this direction. So force on this charge due to this charge that is acting in this direction, right? In this direction. So this distance has to be taken, the distance in the direction of force. So F R21. So I will write as R21. And if I have to specify the distance, so I will write a unit vector here R21. So there will be a unit vector in this direction, in this R21 direction, right? So let me call it as equation first. This is vector. And similarly, R21 force on second due to first, that will be equal to K Q1 Q2 divided by R12 vector R12 multiplied by R12, this unit vector R12. Okay. If I take unit vector is equal to vector divided by magnitude of that vector. So here, if I take this vector R12, as you can see, if I take this vector R12, so here you will see that the triangle is formed R1, this vector, and this vector R12, right, R12, and this is the resultant of this vector. So R1 and R12, they are in the same direction, and R2 will be the resultant of this vector. So R1 plus R12 will be equal to R2. So here R12 will be equal to R2 minus R1. So this is R12. And similarly R21. As you can see in this triangle, R2 and R21 in the direction and this. So here R2 and R21, R2, R21, they are in the same direction. So their resultant will be equal to R1. So here R21 will be equal to R1 minus R2. Okay, R1 minus R2, and here R2 minus R1. So we will take from this equation, first equation, F12 is equal to K Q1 Q2 divided by, instead of R21, I will write the the magnitude of this. Okay, R21, sorry, this is square here, also here square. So for R21 I will write this one, R21 I will write R1 minus R2, but the magnitude of this, and multiplied by R21. Okay, multiplied by R21. So for instead of R21 I will write okay, from here, our this unit vector for R21 will be equal to R vector R magnitude of R21. Okay, and for R12 I will write this is R21. Okay, and for this will be R12 divided by R12 magnitude of R12. So instead of R21 I will write vector R21 divided by magnitude of R21. Okay, magnitude of R21, and that is R1 minus R2. R1 minus R2. So this is equal to K Q1 Q2 divided by R1 minus R2 multiplied by R1 minus R2. So this will be R1 minus R2 whole cube. And for R21, I will write this R1 minus R2. So this is the scalar, vector representation of this force F12. Okay, force on first due to second. And in the same way, I will write F21 is equal to K Q1 Q2 divided by here, you can see, divided by R12 square multiplied by R12 cap. So this is equal to K Q1 Q2 divided by, this is actually equal to R2 minus R1 square multiplied by, and this is equal to vector R12 divided by mod of R2 minus R1. Right, so this is equal to K Q1 Q2 divided by R2 minus R1 multiplied by R2 minus R1. So this is R2 minus R1 whole cube multiplied by, instead of R12 I will write this R2 minus R1. So R2 minus R1. Okay, so this is the vector representation of, so this is force on second due to first. Okay, so this is the vector representation of this law F21, and this is F12. And here this is clear that this force F12, it will be equal to F21 but in the opposite direction, F21. Okay, according to Newton's third law of motion.